Welcome to our deep dive, everybody. Teachers, students, physics enthusiasts.
Yeah.
Today we're diving into something really cool.
Oh, yeah.
Using smartphones to teach and learn physics.
Smartphones.
It's amazing how much potential these little devices have to bring physics right into the classroom. You know, make it real.
Yeah, you think about it.
Yeah.
People think about smartphones as for communication, for having fun.
Right.
But they have these amazing sensors
Oh, yeah.
that open up a whole world for exploring physics.
It's like every student has a little mini lab right there.
Absolutely.
In their pocket.
Like a little physics lab in your pocket.
And the best part is, right, something like 70 to 80% of high school students
Wow.
and even a good number of middle schoolers already have these.
That's a lot of students.
That's accessibility.
Yeah.
That's a game changer.
It really is. It allows us to bring physics to them on their own terms.
Yeah.
With something they already have and love.
Right.
Hands-on learning right in their pocket.
So let's get specific. What kind of sensors are we talking about here? And what kind of physics can we explore with them? There's so many to talk about.
Yeah, tons.
Let's start with maybe an unexpected one, the microphone.
The microphone.
Yeah. Not those old clunky things we all remember.
Yeah, those big clunky things.
Smartphones
Yeah.
have really high-quality microphones
Wow.
built in.
Yeah, they do.
And that completely changes
It does.
how we can study sound, how we can explore acoustics.
Oh, absolutely. The possibilities are endless.
Now let's talk motion. You know those classic physics experiments with moving objects?
Oh, yeah. We've all done those.
What can smartphones do there?
Well, almost all smartphones have not one, but 3 accelerometers.
3.
3.
Wow.
They measure acceleration in 3 dimensions.
Okay.
So many things you can do with that.
Yeah.
Linear motion, gravity.
Wow.
Even seismology, like studying vibrations, little earthquakes right on their desks.
That's amazing. So using these accelerometers,
Yeah.
we can really make those abstract concepts come alive.
Absolutely bring it right to them.
So what else is hiding
What else is hiding?
inside these devices?
Well, most smartphones have these things called magnetometers.
Magnetometers.
Magnetometers. They measure magnetic fields in 3D.
Okay.
Imagine this. Students mapping out the magnetic field around just a simple bar magnet. They can actually see those invisible lines of force that we normally just draw in a textbook.
Wait, so we're talking about actually visualizing magnetic fields using a smartphone.
Yeah.
That's incredible. I can see how that would be so helpful for students to understand these invisible forces, right?
Absolutely. It makes it real. We talk about them, but now they can see them.
Yeah, that's a big deal.
Speaking of visualization, we can't forget about the camera.
Right.
But I'm not just talking about snapping pictures.
No. What else can we do with a smartphone camera beyond, Instagram and all that?
Well, you can film motion for really detailed analysis.
Yeah.
Break it down frame by frame. And get this, we can turn those cameras into microscopes.
Hold on. A microscope using a smartphone camera. How is that even possible?
It's actually a really simple trick, Just a single drop of water.
A drop of water.
On the lens, it becomes like a super lens.
Wow.
You can magnify things all the way down to the cellular level, just a drop of water. You can explore the microscopic world.
That's mind-blowing.
It is, turning this everyday thing
Yeah.
into this powerful scientific instrument.
Okay, I'm hooked. So what are some actual experiments we could do
The real example.
with all these sensors? Like, give me some specifics.
Oh, tons of possibilities.
Yeah.
Let's start with a classic, the resonance of a guitar string.
Yeah.
And you can use, there's free spectrum analyzer apps. You can see this in action.
Ooh, that's a good one. That's something, I remember having trouble understanding back in school.
Yeah, it can be a little tricky.
How would this experiment actually work using a smartphone?
Okay. So students can pluck a guitar string, at different lengths, pressing down on the frets and using the spectrum analyzer app.
Okay.
They can identify the resonant frequency
Okay.
for each string length.
So they're basically seeing the sound waves right there on the screen visualized.
Exactly.
Yeah.
And they can actually plot those frequencies against the string length,
Right.
make a little graph,
Okay.
and they'll see this inverse relationship.
Yeah.
As the string gets shorter, the frequency goes up.
That's how we can connect the formulas to something tangible,
It's real.
something visual.
It's real.
It really shows the power of physics, those mathematical relationships, how they actually explain the world around us.
Absolutely. It's not just numbers on a page. It's happening right there.
It's making those connections, bringing it to life.
Making it real.
Okay, I'm already buzzing with ideas. What other experiments can we explore using these everyday devices?
Well, let's talk about the Doppler effect.
The Doppler effect.
The Doppler effect. You know that change in pitch you hear when a siren passes by?
Oh, yeah, or a race car zooms past. I remember learning about that. But it always seemed a bit abstract, you know?
Yeah, a little hard to grasp.
Yeah.
Well, now we can actually visualize it and measure it using smartphones.
How do we do that?
We can use one phone as a sound generator, emitting a specific frequency,
Okay.
let's say 5,000 hertz.
5,000 hertz, okay.
And then use another phone with a spectrum analyzer app,
Okay.
have someone run towards or away from the listener
Right.
while holding the phone that's making the sound.
Okay.
And you'll actually see how the perceived frequency shifts higher or lower, depending on whether they're coming towards you or going away.
So we can see in real time the frequency changing
Yes.
as the person moves.
Yes. And if you had a runner, say, moving at 5 meters per second, you'd see a noticeable shift of about 75 hertz.
Wow.
And the smartphone can detect that.
That's amazing.
It makes it real. You can see it happening.
This is making me rethink everything I thought I knew about physics labs. Any more game-changing experiments up your sleeve?
How about, we take a little trip back in time and recreate Eratosthenes' famous measurement of the Earth's circumference.
Wait, are you talking about the experiment from, over 2,000 years ago? Can we really do that with a smartphone?
We can.
Wow.
And it's actually surprisingly straightforward. You can use a theodolite app, that lets you measure angles using the phone sensors.
Oh, wow.
Imagine two groups of students,
Okay.
located pretty far apart, maybe even different cities.
Okay.
On a sunny day, same time, they each use their smartphones to measure the angle of the sun.
Okay, so I'm picturing them, both pointing their phones at the sun,
Yeah.
using this app to measure the angle.
Yeah.
Okay, what happens next?
So if they know the distance between those two groups and the difference in those angles, they can actually apply Eratosthenes' method
Wow.
to calculate the Earth's circumference.
It's blending ancient knowledge with modern technology.
It is. It's history, technology, and physics.
That's a great way to engage students.
Absolutely. It makes it memorable.
It shows them, how scientific knowledge builds over time, but those core principles,
Yeah.
they remain the same.
They remain the same.
Wow. Okay, so we've got sound, we've got motion, we've even got astronomy, all with smartphones. I'm starting to see the possibilities here.
It's just the beginning.
It really is.
It's just the beginning. There's so much more we can explore.
But before we dive even deeper into this amazing world, let's just take a moment to kind of reflect on what we've learned so far.
Yeah.
And we'll be right back to explore even more smartphone physics insights in just a moment.
Can't wait.
I know, me too.
It's going to be good. Welcome back to our exploration of smartphone physics.
I'm so ready for more.
Me too. I feel like we're just getting started,
It's really exciting to see all these possibilities.
Mm-hmm. It is. And, before we get too carried away with more experiments, we should probably mention there's two main operating systems out there, Android and iOS.
Right, the software that runs on the smartphones. So how does that play into our physics exploration?
Well, some apps are designed for one or the other.
Okay.
So it's good to, when you're planning an experiment, just check if the apps are available on the devices your students have.
Right, like checking the ingredients before you start cooking. Good point.
Exactly.
So, assuming we have the right apps, what other experiments can we add to our smartphone physics toolkit?
Okay, let's shed some light on things, literally. We can use the light sensor in smartphones to explore a fundamental principle of physics.
Okay.
The inverse square law.
The inverse square law, remember that. It describes how the intensity of something decreases as you move further away from the source.
That's it. Think about how a lamp, it seems dimmer the further you are from it.
Right, right.
That's the inverse square law in action. And we can actually measure this with a smartphone.
Oh, really? Okay, I'm intrigued. Tell me more.
It's surprisingly simple. You need a light source, like a halogen lamp works well, a dark room. And then using a light sensor app on the phone and a measuring tape, students can measure the illuminance. That's the amount of light hitting a surface.
Okay.
At different distances from the lamp.
So they're taking readings, let's say, at 1 meter, 2 meters, 3 meters, and so on, and they're recording the illuminance from the app.
Exactly. And they'll see this pattern. If you double the distance from the light source, the illuminance drops to 1/4.
Wow.
Triple the distance, it drops to 1/9. It's that inverse square relationship.
It's a really clear visual way to see that law in action. And it's not just for light bulbs, right? This applies to other things too, like gravity and sound.
You got it. It's fundamental, governs so many things in the universe.
Wow.
And this simple experiment, can lead to discussions about how we perceive brightness, how it affects photography, even how astronomers study distant stars.
It's making me think about those like astronomy apps,
Yeah.
where you use your phone's camera to identify stars and constellations.
Oh, yeah?
Speaking of astronomy, I read that smartphones can even be used to study exoplanets, planets orbiting distant stars.
Yeah.
Is that true?
It is. It involves a clever simulation of what's called the transit method.
The transit method, okay.
That's one way astronomers discover those distant worlds.
Tell me everything. I'm all ears.
Okay, so we set up a light source, again, like a halogen lamp works well,
Okay.
to represent a distant star, and then, a small sphere,
Okay.
like a marble, acts as our exoplanet.
Okay.
And we move that sphere between the lamp and the smartphone's light sensor.
So we're basically creating like a mini eclipse
Exactly.
using the lamp and the marble and the smartphone.
Exactly. And here's the exciting part. As that exoplanet passes in front of the star, the light sensor app on the phone will actually show a dip in the light intensity readings. And that's the same principle that astronomers use to detect these exoplanets, these tiny dips in a star's brightness.
So we're not just observing, we're replicating the methods that like actual astronomers use.
Yes, we're doing science.
That's so cool.
It's very cool. And by analyzing the shape of that dip in brightness, students can actually estimate the size of that exoplanet compared to the star.
Wow. That's incredible how we can simulate these complex astronomical phenomena with everyday objects in a smartphone.
Yeah, you don't always need expensive equipment.
It really shows the power of like simple models in physics.
It does. And this experiment is sure to get students excited, especially those that, dream of space.
Absolutely. It's going to ignite their curiosity. So we've tackled light, we've ventured into the cosmos. What other areas of physics can we explore with these devices?
Well, let's not forget about those amazing accelerometers we talked about earlier.
Right.
They're not just for measuring motion, they're super versatile.
Yeah, we talked about them for earthquakes, motion in general. What other experiments can we do to really like showcase their capabilities?
How about investigating, one of the most fundamental forces in the universe, gravity? We can actually use smartphones to study free fall, that classic example of gravity at work.
Free fall. That takes me back to physics class, dropping things, trying to time them. But how can we study free fall using a smartphone?
It's simpler than you might think. We just need to attach the smartphone securely to a small object.
Okay.
A tennis ball, a lightweight box, something like that.
Okay.
And then drop it from a known height. Let the accelerometer app record the acceleration data as the object falls.
Okay, I'm picturing it. We drop this phone-equipped object.
Yeah.
The app tracks its motion. What kind of insights can we get from that data? What are we going to see?
Okay, so students can analyze that acceleration time graph that the app records.
Okay.
And what they'll see, it's amazing. The acceleration due to gravity, it's constant throughout the fall. It doesn't matter how heavy the object is.
Yeah.
It's about 9.8 meters per second squared. That famous number.
The one we see in all the textbooks.
Exactly.
So they'd see that classic straight line on the graph.
Exactly.
Showing that acceleration is constant during free fall. It's like a visual confirmation of the equations.
It is. It's one thing to see it in a textbook. It's another to actually measure it yourself and see that data graphed out on a smartphone.
Right. It becomes real. It's a powerful learning experience. I'm noticing a pattern here. We're taking these everyday devices.
Yeah.
We're using them to illustrate those core physics concepts in a way that's accessible, engaging, hands-on.
That's the beauty of it. And, to add even more engagement and a little historical context, we can even recreate those classic experiments from the history of physics.
Oh, I love that idea.
Bridging the gap between past discoveries and modern technology.
Yeah, bringing history to life. It shows how scientific knowledge builds on itself over time. What kind of historical experiments are you thinking about?
Well, one of the most famous, Galileo's legendary experiment on inclined planes.
Oh, you mean the one where he rolled balls down ramps to steady motion?
That's the one. The one that challenged all those old beliefs.
Right.
About how things move.
Yeah, so can we really recreate that using smartphones?
Oh, we can.
I need the details. How does this work?
Okay, so we need a flat board or a track to act as our inclined plane.
Okay.
We can use books to prop up one end to create the incline.
Okay.
Attach the smartphone to a ball or a small cart, something that can roll down.
Okay.
And of course, we're using our accelerometer app to record the acceleration as it rolls down.
So we're basically making like a mini racetrack for our smartphone-equipped object.
It is. It's fun. It's a fun way to learn.
That's awesome.
And by varying the angle of the incline, using more or fewer books,
Right.
students can see how the acceleration changes, just like Galileo observed, centuries ago. Steeper inclines, greater acceleration.
It's amazing how a setup like that,
Simple setup can reveal so much about physics.
it really is.
And it's not just about gravity and acceleration. It's also a great way to introduce concepts like vectors, components of force, how to analyze motion in 2 dimensions.
So we're hitting multiple physics concepts
Multiple concepts.
with one experiment. It's like a physics multi-tool.
It is. It is. And the best part, you can do this experiment anywhere. Classroom, hallway, even outdoors.
Smartphones really are breaking down the walls of the traditional physics lab.
They are. The world is our lab now.
I'm feeling so inspired by all of this.
Me too. It's exciting.
It seems like the world is our laboratory now.
It is, and we're just scratching the surface of what's possible. As technology keeps evolving, so will the potential of these devices to unlock the secrets of the universe.
It's an amazing time to be a teacher and a student of physics.
It really is.
I'm already thinking of new experiments.
Yeah.
But before we get too carried away, let's take a quick pause, gather our thoughts. We have even more smartphone physics wonders to uncover after the break. Welcome back, everyone. I'm still buzzing from all those incredible experiments.
Me too. It's amazing how much physics we can do with these things.
Right. It's really opened my eyes to the possibilities.
Yeah, and we're not done yet. There's so much more we can explore.
Okay, I'm ready. What other physics gems are we going to uncover today?
Well, we've talked sound, motion, light, even gravity. But what about magnetism? Remember those magnetometers we mentioned?
Of course, the sensors that let us see magnetic fields, right, in 3D. I'm really curious about that one.
Yeah, it's actually pretty straightforward. All you need is a magnetometer app
Okay.
and a small magnet.
Right.
Students can move the phone around the magnet, measure the field strength and direction at different points.
So they're not just seeing a static picture, they're interacting with it, seeing how it changes.
Exactly. And they can take it a step further, even plot those readings on a 3D graph. Oh.
Create a visual representation of the field lines.
So much better than just a textbook diagram.
Way more engaging. It's like they become magnetic field explorers.
That's a fantastic way to learn. And it's not just static fields, right? We can explore how they interact with conductors, too.
Absolutely. Bringing electromagnetism to life.
Ooh, how do we do that?
Simple setup. A coil of wire connected to a battery.
Okay.
Move the phone's magnetometer near the coil. See how the field changes when current flows.
So they can see how electricity creates magnetism. It's like a mini demo of electromagnetic induction.
Precisely. And that's a fundamental concept behind so much technology we use every day. Generators, electric motors, all that.
Wow. It's incredible how these simple setups can illustrate such powerful ideas.
It really highlights the potential of hands-on learning and how smartphones can make physics relatable. It's not just something in a textbook.
Absolutely. So as we wrap up this deep dive into the world of smartphone physics,
What are some key takeaways for teachers and students ready to embark on this journey?
well, first and foremost, don't be afraid to experiment. There are so many resources out there, apps to explore, and the learning curve isn't that steep.
Right.
Start with simple experiments, get comfortable with the tools, and then gradually explore those more complex concepts and setups.
That's great advice. And I think it's also important to encourage students to take charge of their learning.
Absolutely.
Let them explore apps, come up with their own ideas.
Yes, let them design their own investigations.
Exactly. That sense of ownership and curiosity, that's where the real learning happens.
It does. It's about empowering students to become scientists themselves. Not just memorizing facts, but figuring things out.
And at the end of the day, it's important to remember, smartphones are just tools. The real magic is using them to spark our imaginations, ask questions about the world, and explore the wonders of physics.
Perfectly said. Physics is all around us, waiting to be discovered.
It is.
With a little ingenuity, a smartphone in hand, we can unlock those secrets. Bring the universe right into the classroom, right into our lives.
It's been an amazing journey exploring all these possibilities.
It really has.
Thank you for joining us on this deep dive into the world of smartphone physics.
Thanks for having me.
And we hope you feel inspired to grab your phones, explore, experiment, and discover the wonders of physics all around you.
Happy exploring, everyone.